中意 open。Okay. Okay, so let me share the screen. Once again, it's a Zoom problem. Okay, it's not my problem. Okay, so don't bring me. It's a Zoom's problem.
Sir, 好似有人咧最新嗰條 link 都入唔到嚟。
最新嗰條 link 都入唔到啊？咁大鑊！唉，咩料啊？而家74呢個數字啊！冇理由限制於74咁搞笑㗎，咁零丁嘅。唉，你點搞咧？新 link 都入唔到，冇辦法咁樣，真係唔通要？唉，我整埋 Google 㗎啦 ，Google Meet 啊，得唔得嘅咧？開兩個，應該唔得嘅噃。
你睇電腦食啦。
得咗係嘛？咦，好似有上升緊喎。咦，點解跌咗嘅喂？76跌翻75嘅。你幫我
有人手機入到嚟。
手機入到嚟。哦，咁都 OK 啊，頂住先咯。係啊，邊個入唔到嚟？大家幫我通知佢。手機頂住先。
你要記得錄啫。
我記得錄係嘛？知道，收到。咦，頭先你唔係入過嚟嘅咩？ You just came in by mobile phone。係咯，頭先見到你打 message 㗎。Okay, so I need to start first. Now, for those who cannot came, please help me to ask them to log in by using mobile phone or iPad, I think. Okay. Okay, remember last time we have talked about the line integral, right? Okay, thanks for coming to my class. Today I give you a hard time, so it's difficult to come here, right? So hope that you can still enjoy the class. Okay. Okay, let's get started. Okay, remember I've told you the line integral, right? What is the working principle of the line integral over this one? You can see that this one will have the dot product over here. So this version of the line integral is to make the work done. Once again, to make the work done. So in order to do that, let's see what is the F first. You may think about F is the force, okay? The force is in the direction x plus y, I, plus 1 minus xj. And how about the curve? The curve is at the proportion of x squared over 4 plus y squared over 9 equals 1. Okay, do you still remember this one? Is what? It's the ellipse, right? Remember last time I've told you that how to convert the ellipse into the by using parametric form to write the ellipse into x and y. Okay, so in order to do that, okay, let me remind you this, we have talked about this last time, right? So if we are going to have the clockwise direction of flowing, x equals to a, that means this one, this horizontal length cosine t, and y equals b sine t. Okay, so I copy here because they are asking about the clockwise rotation. And in the which quadrant, you can see that this one is at the 4th quadrant. Can you see that? So if it is the case, so they are moving from -3 to 2 over here. So let's see. Okay, because of x squared should be over a squared, so a equals 2. And y squared over 9 is to be over b squared, so b equals 3. Got it? Yeah, because this is the length, so we don't have the negative sign. So a is 2, b is 3. And so let us think about by using parametric form, so x equals to 2 cosine t and y equals to 3 sine t. So now because of the curve C can be represented by the RT, so we write down RT equals this. This is x, this is y, 2 cosine t and 3 sine t. And how about the range here? Because we are on the 4th quadrant, so the t should be starting from 3 pi over 2. That means 270 degrees to 360 degrees. So it should be 2 pi. Got it? So this is a step 1. Okay, so how about the FRT over here? Let's see. Okay, first of all is that FRT equals 2 cosine t plus 3 sine t, and the bracket times the I plus 1 minus 2 cosine tj. Why? Because I substitute x and y equals to 2 cosine t and 3 sine t into the original force formula to get it. Okay. Okay, and then the step 2, we further differentiate with the R by using t. Okay, so this is the R. If I differentiate by using partial derivative, no need partial derivative because you only have one t. So differentiate cosine t, we have negative sine t and multiply with 2. So we have negative 2 sine t I. And differentiate this one. Differentiate side, we have cosine. So we have 3 cosine t here. This is vector form. Okay. And the next step is that step 3, we dot these two together. Okay, so by using dot product, so that this one multiply with negative 2 sine t plus another highlighter. Okay, 1 minus 2 cosine t multiplied by 3 cosine t, and then expand this. Okay, etc., and then to group it. Okay, and you can see that here, once we have group sine square plus cosine square, what we have is 1. So becomes minus 6 times 1 here. Okay, how about the next one? The next one is that you can see cosine t sine t. In fact, 2 sine t cosine t. Remember last time I've told you that it should be equals sine 2t by using double angle formula. Got it? Okay. So here we go. We're going to integrate this. Now, okay, got it? Okay, so we integrate from 3 pi over 2 to 2 pi. This one dt, and then finally, just now I remind you again over this. This one equals to 1. Okay, so by using simple integration, and then you can have the answer 5 minus 3 pi. I think it's pretty easy to have this, right? Okay, the most difficult part is that if curve C is represented by one of the formula, one of the equation here, you need to think on your own how to change x and y into parametric form. It's based on your experience to do that. Got it? Okay, I will tell you more and more about 2D curve, 2D graph, and 3D graph, how to use parametric form to substitute into X and Y. Otherwise, you don't know how to do this. Okay, got it? Okay, that's all for this part. Not difficult, right? Yeah, how can I know the range is a 3 pi over 2 to 2 pi? Because they have mentioned that is at the fourth quadrant. So the fourth quadrant should be from 270 degree to 2 pi to 360. So 270 degree equals 3 pi over 2. And 360 equals 2 pi. Okay, got it? Okay, please wait a moment, everybody. I think I need to launch a phone call to tell the Zoom that I have a problem. Hello Jasmine，喂你好啊，我係 Frankie 啊，頭先咧個 Zoom 嗰度咧，我哋兩個開房啦，connect 極都 connect 唔到，咁所以咧就變咗我用另一個 Zoom ID 咧先 connect 得到，咁我用自己個 personal Zoom 嘅，咁我一陣間仲要再上多，而家我用咗另一個 Zoom ID 啦，咁啊上到啦，咁其實而家咧70幾個人，但係仲有啲人咧入咗我82個人嘅，咁仲有啲人咧都仲未入到嚟，咁呢個已經好嚴重嘅問題啦。咁另外我4點半又有另一班，又係82人。如果佢再咁樣搞，我真係死俾佢睇嚇。咁你介唔介同我反映俾 ITSC 聽，叫佢幫我搞掂咗佢嚇？我而家上緊堂嘅其實係，所以我唔方便講太多嘢。咁但係你幫我同 ITSC 講，叫佢無論如何點都搞掂翻佢。如果唔係我死俾佢睇，係啊，唔該你 ，thank you，唔該，拜拜，拜。喂，咦，好似唔記得熄咪添，聽到晒我講嘢。Hello， hi， 係啦，而家for the fourth quadrant, no need to include x, y axis because all of the things becomes t. All of the things becomes t, right? Yes. Yeah, all of the things becomes t. So you no need to think about x and y already. Got it? Okay. Because for clockwise rotation, okay, clockwise rotation from here up to here, okay? So a period of t is should be from 0 to 2 pi. So this one is 1/4, a quarter period, okay? Yes, I think it's difficult for you to know how to set the range, but you need to try. Got it? Okay, thank you. Hello. Yes. 而家大家都知我今朝先上完堂，咪都係嗰條 link 啫嚇，一絲事都冇噶嘛，無啦啦搞啲咁嘅嘢，股價跌唔好搞到我哋啊！Okay, so next part is that I would like to let you know the properties of the line integral of vector field. What are those properties? Okay, let's see here. First of all is that I think it should be easy. If we have the constant k besides the vector f, so please put the k to the left side. Okay, this is the first thing. And the second thing is that we are going to integrate this one, f plus g, both F and G are vector field. Got it? So we can separate the integral. So which can be integrate from integrate F dot dr plus integrate G dot dr. And then the last one, I think it's easy. If you are integrating from the curve, starting from A to B, A is over here, B is over here. If there exists a point P in between, okay? So what you're going to do is that you can separately integrate the first one based on the curve 1, plus integrate the second part based on curve 2, and then finally adding them together to calculate the answer. I think it's pretty easy for this property, right? I think all of you know that. If I've never mentioned, okay, but in the sense of completeness, you should know that. And how about the direction? Okay, now I'm going to integrate like this. Okay, that means going upward. How about if I going downward? If the curve C or the dr, the r vector is going downward, okay, it's pretty easy that if I add the negative sign over here, so it equals to the direction reverse. Okay, that means going upward equals to going downward curve have the minus sign. Okay, I think it's pretty easy. Got it? No matter you have the negative sign besides the C or in front of the integral sign, is also fine. Got it? Okay, let me guide you this one of the example by using physics that F external is over here, and then F is going behind like that. Okay, so there exists the, if we are going to move, because they consist of work done, right? We are going to move to pull the block, the displacement S. Okay, so what will be the work done? Okay, that's easy. Assume no KE gain and PE equals 0. So that means negative work F times S. Okay, F times S should be equals to F external. Okay, that means I physically pull it, so it's a F external times the S. Okay, so I can think about like this. So F dot S is in the reverse direction, right? It should be equals to negative F external times S. Got it? If the block is moving at constant speed, constant velocity. Got it? So that means the R, okay, or the F is different. Okay, we add the negative sign, can be the reverse one. Got it? This is a simple example. Once again, if you would like to be work better in this subject, if you haven't studied physics before, I strongly recommend you learn back the physics in the secondary school level physics. It helps. Okay, otherwise, after you learn the mathematical calculation, you don't know how to apply. I don't think it's no use. Yes, for example, you are going to integrate from point A to point P. You need to know the range of A to P. Okay, you need to know the coordinate of A, coordinate of P. Otherwise, you cannot use the third property to do that. Okay, you need this. Yes. Okay, something like here is negative work like clockwise direction, positive work like anti-clockwise direction. So if at the negative sign, it reverse. Okay. I think it's not difficult because you just know that at the negative sign, you can reverse anything. Okay. Got it? We finished for this part. Okay, another one I would like to let you know is about the conservative. I think I've told you this word before, right? In the curl F, in the curl F part. Okay, let's see here. Let's F, something like the force, you think about the force, or the function capital F is the continuous vector field. That means this vector, it will be moving continuously. Got it? Continuously. And the next thing is that F is a conservative vector. If there is a function smaller than F such that capital F equals to del F. Do you still remember del F? Del F is gradient of F. Got it? Gradient of F. So the F is called the potential function. I think I've told you this relationship. Okay. What is meant by domain? Domain, that means the space, the point occurs in xy plane or xyz plane. We call it the domain. Okay. Or for all input variable, it's also called domain. Okay. That means all input values is called domain. Okay, so in order to elaborate this, I think you need to know about something called independence of path. Okay, before I told you this, I would like to let you know about some of the curve property, some of the path property. Here we have some keywords called closed, simple, open, collected. What's that? In fact, okay, let's see here. This one, I can call it simple. Okay, why we can call it simple? Because they don't have any intersecting point. They don't have any intersection. This one also simple because they don't have any intersection. They don't have cross. What I mean is that they don't have cross over here. Got it? However, what are the difference between these two? This one is that it's closed. Okay, that means if we go back to the starting point, so I call it closed. And this one, simple, but it's not closed. Why? Because the endpoint haven't go back to the starting point, so it's not closed. Okay, got it? Okay, so okay, so let's see. The next one is that yeah, just now close and simple. Yeah, simple. Remember, we don't have any clause on this. Okay. Got it? Okay, next one is that how about if I call it not simple? Okay, not simple because you have a crossover here or the intersecting point over here. We call it not simple. But because it will go back to the original point, right? So I also call it closed. Got it? How about this one? This one, of course, is not simple because we have cross and also not closed. Got it? This is the technical term. You should remember this term. Okay. Okay, the next part is that we call it D is open region. I'm not talking about the path. I'm talking about the region. This is a region. What is mean by open? Okay, let's see. Open, that means something like this kind of shape. We don't have what? We don't have the boundary. It's just, it seems like it's open end, open boundary. But this one, you have the path over here. Can you see that you have the path to enclose this? So we call it, yeah, closed. Okay, closed. but maybe we call it not open. Got it? Call it not open. We call it collect. Okay. So, but this one we don't have any boundary. Okay, so you can extend to no matter infinity. So we call it open. Got it? No boundary point. However, now I would like to let you know about what is meant by simply collected region or collected region. Okay, for example, this is the gray area is the region D, region D. How about the curve over here is the C, curve C. Got it? Region D, we call it simply collected. That means we don't have any holes in between. You can see that this is a region, this is a region. Don't have any hole like below. So if you don't have any hole like below, okay, so we call it simply collected. Okay, let's take a look up below part. That means a collected region that is not simply collected because we have the hole. Got it? Okay. So once again, so what is meant by collected? Okay, collected. Collected, that means there is 2 points over here, 2 points over here, and then we can use the curve C to draw something out to enclose a path. So we call it collected. So of course, the enclosed region, we call it D. Got it? Okay, once again, this kind of keywords you should remember. Sometimes in the examination or in the assignment, we won't draw the path for you. We won't draw the region for you, but we just tell you about which is simply collected or not simple but close region, and to ask you to find the answer or to solve the formula. Okay, this is the most difficult part of the question, I think. Yeah, if you don't have idea of this kind of keywords, you ignore this keyword, you don't know the real meaning of this keyword, and then you cannot do anything. Got it? Okay, so that's for representing the shape for you. I'm in a hurry today because I need to describe all the things for you faster because we have a half hour disappear, right? Otherwise, you cannot do any classwork. Okay, another thing about the conversion between conservative and also potential function. Got it? Okay, so let's see. Okay, so once again, F is a capital F is a continuous vector field in the domain D. That means in this kind of domain. Okay, and if F is conservative, that means which is equals to the del of the potential function F. Got it? Okay. So let's see below. What's that? What does it mean? Okay, I would like to let you know about two physics application. Okay, if you haven't studied physics before, try to get the idea. Okay, try to get the idea. Okay, first of all is that when you are going to have extra force to pull the object upward, okay, that means you are going to pull something upward, pull something upward, okay. And the work done vertically is a F dot dr. R is the direction that you're moving upward, okay. Equals to what? Equals to the gravitational PE. Gravitational PE equals to mg delta h. Got it? Because h stands for height. The height is in the right direction, okay? So I can simplify into mg delta y because it's in the y direction. And finally, I call this to be delta u. U is the variable to describe the potential energy, or describing energy is also fine. Delta u. So can you see that? Integrate this work done. It becomes the delta u. Delta is something like the difference between, right? Difference between. Now, if I reverse this, if I change the integration sign, becomes differentiate this one. Okay? So it becomes what? It becomes del. I would like to remind you that these two sides are different. These two sides are different. Okay? This is delta. This is del, or another name called neighbor. Okay? This one is a gradient of u equal f. And this one is called delta. It's just a difference. Okay? So what are you saying? Once again, if the capital F, I would like to get it by using u. I use delta u to get it. Another version is that if I would like to get back the F, I use del u to get it. Got it? It's different. Okay? Do you know what I'm saying? Okay, so yeah, this is the problem you are talking about. Okay, you need to know these two relationships. Okay, got it? Okay, digest this first. Okay, digest this first. Now, think about this. I give you 30 seconds to digest this. Okay, it's important. Okay, so let's see how can we get the F out over here. Okay, so in order to now I have this one. This is a delta U, right? So it's a mg delta y. So in order to find out the F, just now I have asked you to remember it is the del over here, del U. You find the gradient of the U, and then you can get back the F, right? Okay. So think about this. If I use a partial derivative to work out this mg delta y, differentiate this with respect to x. So here we don't have x here, so it becomes 0. And next one, partial derivative according to the y based on this one, this formula. Okay. So we have the delta y here. So partial derivative, this one, this is I can treat about delta y to be dy. So differentiate this one, we got 1. So it becomes mg. Okay. And then the last one is that it is the why it is 0, because partial derivative according to the set. Okay, because we don't have component over here based on the set, so it becomes 0. So that means turn out it formulate the force vector equals to mg. That it, force vector equals to mg. Okay. Yeah. Here I ignore the direction. Okay, the direction. Okay, but yeah, equals to the mg. Okay. That means what you do is the force pulling upward equals to the weight, mg equals to the weight, okay, of the material over here. Got it? This is one of the application. Okay, how about another application is the electrostatic force. Okay, here we have the extra force to pull the charge carrier to gain the electrostatic PE. So what's that? This is the electric field in the physics. Okay, when there are two parallel planes over here, and then electric field is set up between these two planes. Okay, so when we have the positive charge here, it will be the direction has problem. Okay, no problem. Sorry. If I would like to move this positive charge to here, okay, to here, yeah, they need to have extra work done. Why? Because it violates the lateral phenomenon of unlike charge attract. This is positive charge, right? This is negative plane. Positive charge and negative plane should attract to each other. Got it? Now I need to do the extra work so that it violate the normal, the lateral attraction between this one, these two. Okay, so we need to do the work. Got it? So once again, for parallel plane, we have the formula like this one. The potential difference between these two equals to the E field times the delta D. Delta D is a separation between the parallel plane. Got it? So okay. Yeah, we are going to do is that integrate the F dot dr equals to Q delta V. What's that? Okay, once again, this is the work done. The work done equals to what? The gain of electrostatic PE. This is another kind of potential energy. We call it is the electrostatic PE, which is equal to Q delta V. Got it? And which is equal to Q times the, because just now I substitute this formula over here, this formula, okay? Because we're going to do the work, okay? Need to substitute this formula into here to replace the delta V. And once again, I call it the delta U, okay? Total energy, we call it delta U. Now, once again, if I would like to find out the force again, I need to calculate the del U. Okay, so we try together again. So because of the D here is the X, the direction of X, right? So differentiate this according to the partial derivative on X, so it becomes QE. Got it? And how about partial derivative according to Y and Z? Nothing appear. Nothing X, sorry, nothing Y, nothing Z appear over here. So it becomes 0. So finally, we have the formula called force equals QE. You need to move to the left to work on the work done. It's just like this one. The force is equal to mg. To net, you know that it's moving upward. Got it? So this is the application of the conservative and also the potential function. Okay, this is the potential function. Once again, in order to find out the potential function or find out the line integral, to find the vector field inside the line integral, we use the del is okay. Got it? Okay. Okay, so once again, del the potential function, and we have the conservative field out. Got it? Okay, so let's see. Here I would like to prove something extra. Okay, let's see. F is a conservative vector. That means what? We use a del F, and then we can calculate the answer of this conservative vector. Okay, this is the first thing you need to remember. Every time the salad is conservative, remember to use this formula to find the F. And the F, another name is called the potential function of the vector field. And what is the benefit of defining conservative and potential? In fact, you can see that it is very easy to use a delta, the scalar U, delta, the scalar U, to calculate the answer. What is delta? Delta, that means final value minus the initial value is a delta, right? So that means this one, which is exactly equals to integrate the capital letter F dot dr equals to F final destination minus the F the destination minus the F the initial value. Once again, the function of final, the potential function of final minus the potential function of initial point. Got it? Because it's equal to delta F. Okay. That means if the scalar A, scalar F is over here, this is the starting point A, this is the end point B. So what we need to do is just f at b minus f at a is already done. No matter how the path is what, it can also do that. The path is something like moving upward or moving downward and what other things is also fine. Okay. Got it? What's more is that we don't because of f is conservative vector, another benefit is that in order to calculate this integral, we are no need to work out the integration. Cute, right? Work out the integration, but you have no need to work out the integration. What are you talking about? In order to do this integration, you just put the function of the final point minus the function of initial point is okay. Got it? Okay. Okay. Okay, this is the proof of why we can do that. Okay, first of all, we write this formula here, and from A to B, del F dot, del F dot dr can be represented by dot R dash T dt, right? First thing. Okay. And now I use this because XYZ is now in terms of T already. And then what I would like to do is to perform the dot product. So it becomes this one, because our T is this one. So by using the chain rule, so R dash T equals to X dt over here, and dy dt over here, and dz dt over here. And then next thing is that del f is del f del x del f del y del f del z. Got it? So after that, that means what you're going to do is to differentiate, because those dx, although dx, dy, and dz are something like cancel out. Okay, so what you're doing is the del f del t, del f del t, del f del t. Okay, can you see that what we're going to do is that we are integrating the differentiation of something. Got it? So it's stupid. Integrating the differentiation of something, so it should cancel out. So finally, it becomes a function, potential function of B minus potential function of A. Got it? So that means we are no need to think about the path, where from A to B is which path. And also we are no need to do the integration for this one. So it makes all the things much easier. Got it? Okay, finish. Okay, please wait. 未上堂，你繼續講，你講。哦，都係解決唔到嘛？咁佢有冇話係過幾多人先會咁樣？唔關人做事啊？哦，好，唔該晒 ，OK， 唔該，好唔該 ，thank you。我啱啱同事過嚟搞我，就係話咩？佢話係 Zoom 呢兩日都係咁喎，咁所以就辦法啦嚇，咁要諗啲 contingency plan 咁樣嚇，唔可以淨係依賴一樣嘢。好，你拍完咗啦嚇，咁跟住繼續。Okay, we try to work out some of the example, like here. You are asked to evaluate the del f dot dr, where f is equal to cosine blah 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 plus sine pi y minus xyz, and they tell you that the path is starting from this point to this point. Got it? Okay, recognize this now. Integrate the del f dr. Okay, so what is the working principle of this? Okay, think about the del f is a conservative function, capital F. Okay, so in order to use the del here, so you can simply, there exists a vector capital F should be conservative, which is equal to del F. Okay, like this. So in order to work this, so no need to have the vector R to be given. Okay. Now you can just substitute those things into the formula to get back is okay. So think about the RT, which T is in between A and B, starting at the point from 1, half, and 2 to the end 2, 1, and negative 1. So RA is this, and RB is this. Okay. So if it is okay, so let's see here. So I can treat about this vector to be the position vector of OA. RB, this vector should be the position vector of OB. Okay. So if it is okay, so integrate del f dot dr is to be equals to the potential function of f at this position minus the potential function of f at the initial point. Okay, potential function of f at the final point minus potential function of f at initial point. Okay, so what is small letter f? Function is this one. So we substitute x value, x equals to 2, so that it becomes 2 pi. Okay, plus psi pi y, that means psi pi times 1, minus 2 xyz, that means 2 times 1 times negative 1. Okay, and minus another set of function, so cosine pi times 1 plus psi times pi times y is 1 over 2, and minus xyz again, 1 times half times 2. Okay, and finally we can get the answer is 4. Okay, Got it? Okay. Remember, we are no need to calculate the del F, but we need to make sure the del F is already okay. What does it mean? In order to use this method, you have you need to make sure the del F exists. So try to differentiate, try to work out the partial differentiation on x, y, on the according to x, according to y, according to z, to see whether the value exists. And most of the time it exists, okay, because of differentiation property. Okay, if it exists, so we can use this function, this working principle to work it out. Got it? Okay. Here we go. Okay, so although I have something to teach for you, but I think that is pretty enough, and you can handle the class today. So don't be upset by the Zoom. Okay, and we are going to do the class now. It seems that's just me upset by the Zoom, okay, right? Yes. Okay, here we go to my website and the assignment area. Assignment area and click this. Okay, to work it out. And once again, the password is to be Frankie. Capital F, small letter RANKIE. Okay. Open it. Okay, and try to do these two questions. Okay. Okay, question 1 first. Okay, here we go. I think I need to give you a little bit hints to do this kind of question first. Okay, first of all, you are asked to work out the line integral or the vector field, right? And the first half is a circle in the clockwise, in the anti-clockwise direction, and another half is what? It's based on this formula to go this. Okay, so that means the first half you need to use the parametric form of circle to write it out. Okay, think about the parametric form of circle to do this. Okay, once again, first half is a circle, use the parametric form. Second half, you use the formula y equals x squared minus 1. Okay, think about this. Okay, in order to let you to work easier, so maybe I give you the parametric form, but if you can think about this, of course, it's much better because in the examination, no one will give you this. Got it? Okay, so for curve one, okay, what I suggest is that you need to use the parametric form of the circle. We have 1 cosine t and sine t, and for the t equals from 0 to pi over here. Got it? And for C2, just follow the formula to work out this. Okay, what formula is this one? Y equals to x squared minus 1, and change the t into t is okay. Okay, so t equals from -1 to t equals 1. So in this range, okay, you do that. Got it? So let's get started. I would like to show you the, I would like to give you the music, right? Okay, the timer. At this time, I found a software much easier, I think. Everybody's looking for something.
Say you slow it down, not right now. Then you wink at me and we'll complain. Let it be, let it be, let it be known. Hold on, don't go. Touching and teasing me, telling me no. But this time I need to feel you. Ride it, I don't wanna alone. Ride it, just lose control. Ride it, my soul. Ride it, let me feel you. Ride
Okay, finish. Okay, so let me know the answer for this. Okay, so for the integration for the first part, I think is already quite difficult, right? Okay, so it's this one. By substitute the x equals cosine t and y equals sine t into the original F formula and use the dot product with the r dash t. So we have this. Okay, this one is a r dash t. Okay, got it. Okay, how about the second half? The second half is this one. This is the curve 2. Where is the curve 2? Curve 2 is that the lower half from -1 to the 1 here. Okay. This is the second half. And finally, what we're going to do next is that we are going to sum them all. Okay, by adding these two integral together, and then we can have the final answer of this. Got it? Okay, so try to think about whether it's okay for you. So let you to enjoy the music first.
Dressed up a little better, no regrets is what we say. We can't go back in, darling. Nobody said that it would last forever. That doesn't mean we didn't try to get there. I never said that we would die together. That doesn't mean it was a lie. Remember, nobody said that it would last forever.
Okay, another question. You are asked to calculate the integration of del f. I think you can use the the function of the F final minus the function of the initial to work out. Okay. Once again, you can use a function of the final point minus the function of initial point to work out. Okay. Try to do this. Okay, 5 minutes. Okay, you may start now. Okay, so that should have the answer for question 2. I think the answer is pretty easy, and okay, just get to know the value of the final point and also the destination point. Okay, that means like this. Okay, of course, first of all, you need to check about whether you can calculate the del F. Okay, I think is yeah, that means you differentiate each part according to the x and y partially, and I think of course you successfully do that. Okay, so think about the final point and initial point and also the final point by substitute t equals 0 over here and t equals 2 over the r, and then finally we have these 2 points, the position vector, right? So what we need to do is that we need to do this now. Okay, so substitute the function of the second point minus substitute the function of the first point, and then you can get the answer. It is equal to -4. Got it? Okay, Sarah, do you have any problem for this 2 question? I think this 2 question is pretty easy, right? Okay, thanks for coming to my class today, and I'm sorry that today's have some accidents, and I have report those issues to the related parties, so hope they can resolve that no accident will be happen again. Okay, sorry that today's content is not too much. I think that it still can let me to explain all the important concept to you through this lesson. So thanks for coming. Okay, bye bye everyone. Thank you. Thanks for coming today. Bye bye. Thank you. Bye bye. Bye bye. Bye.
咁第3條係咪下次做？
第3條之前做咗㗎吓，之前做咗，我唔記得 delete 咗吓 ，sorry。係啦。Okay. Okay, bye bye. Bye bye everyone. Bye bye. I need to leave now. Sorry for the hurry today. Yes. Yes. Yes, yes, yes.